If you thought we could get through an entire conference on performance without talking about DevOps, I'm sorry, you were wrong. I'm going to be talking about that because performance is not just about the performance of our applications, performance is also about the performance of our teams. So that's what I'm going to be talking about, team performance and how we can measure that and how we can improve it. So this comes from some work I've been doing for the last 6 years now with Dr. Nicole Forsgren. She is the principal on this research program, working with Puppet and Google and Gene Kim and a bunch of other folks on gathering and analyzing data to understand how to get better at software delivery. So this started off talking about DevOps. DevOps famously has no definition. Google Cloud, we have a definition that we put together as an organizational and cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders. So we've all seen organizations who do really well. We've also probably worked on teams that have done really badly. And what we wanted to do is understand how you build high-performing teams and how you get better at software delivery. And in order to do that, we wanted to do science. So although this is about culture and teams, it's also about data and science, which is why I think probably people will be interested in how you do science on something as apparently soft as team and organizational performance. So when you're doing science, we're doing something called predictive analysis. So we're making predictions based on theory and data and so forth. And when you're doing science based on predictions, you need to be doing one of three things. You need to be doing either randomized controlled trials, which is the gold standard for example, drugs and medicine. We can't do that when we're looking at software teams. Firstly, because there's just a lot of variables and they're very difficult to control, and also because they interact in non-linear ways. If you take a really good team and you put it in a different room where there's no natural light, that can massively impact the productivity of a team. So trying to control variables and do randomized control trials in looking at team performance is really, really hard. And that's why you don't see those kinds of studies done. Secondly, you could look at longitudinal data, which means following teams over time. Again, we don't do that because, again, just finding teams that you can follow over time and work on things like controlling variables is really, really hard and expensive. So what we do is something called theory-based design. And what that means is we take theories that have already been written up and tested in the academic literature. And based on those theories, we design experiments, and then we gather data and we test and we find out whether the experiment works or not. And that's what allows us to say that we are doing predictive analysis. We're talking about how something predicts or impacts something else. Where we don't talk about prediction and impact, what we're doing is actually just correlations. And correlations are interesting, but you have to be super careful about correlations. So Tyler Vegan has a really good website, tylervegan.com, which talks about spurious correlations. And he's got a whole bunch of fascinating spurious correlations, like the fact that per capita cheese consumption is correlated with the number of people who died by becoming tangled in their bed sheets. So you have to be super careful about correlation. We talk about it sometimes, but mainly we're going to be talking about prediction and impact because we have done theory-based design. So the number one thing we found in 6 years of doing this research is that software delivery actually matters. We were told for quite a long time that software delivery is, it's nice, but it can't create a competitive advantage. Some of you will remember Carr's book, IT doesn't matter, and he had an article in Harvard Business Review saying that IT doesn't matter. What we find in our research consistently year over year is that firms with high-performing IT organizations were twice as likely to exceed their profitability, market share, and productivity goals. So your ability to deliver software rapidly, reliably matters. We actually also verified this matters for non-commercial outcomes that we all care about, such as the quantity and quality of the products or services that we deliver, operating efficiency, customer satisfaction, and our ability to achieve organization and mission goals, for example. The next question that you should be asking is, what is software delivery performance? How do you measure the performance of your software delivery capability? And what we were able to do is find 4 key metrics that enable you to measure your software delivery performance. So if you're looking at how you're doing on this, these are the 4 things you should measure. And there's a 5th one, which applies in the case of building websites or SaaS systems. So the 4 key metrics that we gathered, 2 measures of throughput or speed, which is lead time. How long does it take you to get changes from version control into production? Deployment frequency, which is how frequently do we release to production? And then 2 stability metrics. Change fail rate, when you push out a change to production, what percentage of the time do you need to remediate in some way? And then time to restore, when there is some kind of incident in production, how long does it take you to remediate? If you take only one thing away from this talk, it should be this: high performers are not trading off speed and stability. High performers are achieving higher rates of speed and higher rates of stability, and also higher rates of availability as well. So all these 5 things go together. High performers are not making trade-offs. So when you hear people talk about moving fast and breaking things, that's actually not what high performers are doing. High performers are moving fast and achieving high levels of reliability and availability. The numbers that we have for this year, what we find is that we do what's called cluster analysis, for those of you who are stats nerds, on the data that we get back from the surveys that we run. And the cluster analysis, we typically get 3 or 4 clusters back. This year we got 4 clusters, and what we find is, I mean, when you do cluster analysis, you don't give any hints to the cluster analysis. You know, we want these ones to be high or these ones to be low. They just come back as clusters, and you get what you're given. And so that's always my biggest worry when we analyze this data, is how's the cluster analysis going to come back? Are we going to find, as we always do every year, one cluster that's really good at everything, 1 or 2 intermediate clusters, and then a cluster that's really bad at everything? And that's what's happened every year, which is why we're so confident in these results. Over 30,000 data points gathered from thousands of companies worldwide over the last 6 years. This is always what's happened. So this year we had an elite performing group that is deploying multiple times per day. It takes less than a day for changes to get out to production. It takes them less than an hour to restore service in the event of an incident, and a change fail rate of 0 to 15%. At the other end, the low performing group, they're deploying changes between once a month and once every 6 months. And it takes about that long for changes to get out, basically because they have to release in these big batches. They're using kind of a project model. They do these long, big batch releases that are months worth of work that take months to deliver. And so all your changes, whether high value or low value, whether urgent or non-urgent, all get delivered at the same glacial pace. And then they're delivering, in the event of an incident, it takes them between a week and a month to fully restore service, which is kind of a crazily high number. And what we think is going on is that in the event of, for example, a security issue, you might be able to somewhat restore service quickly, but it might take you weeks to do the necessary data changes to fix all the issues in your databases and so forth. And typically in large distributed systems, this is what we find. It can be quite complex to fully restore service. Change fail rate of 46 to 60%, which again is pretty high. So also what we find is that if you're an elite performer, you're much more likely to have high availability and be able to make good promises about your availability than if you're a low performer. Just because people always ask this, I want to emphasize that this is true across all different types of company and all different sizes of company. The data from 2014 to 2018, we looked at the firmographics. We find that 25% of our data comes from companies of 10,000 or more employees, so some pretty big companies. We also gather data from financial services, telecoms, government, healthcare, insurance, highly regulated industries, energy. So this stuff works even if you're in a large, highly regulated company. And what we typically find is that in a large company, there'll be little pockets of high performance and pockets of low performance too. So if you're working at a big company, they tend to be very heterogeneous, and you tend to see variations in performance across the company. So if you are a medium or a low performer, obviously you want to get better. And so the bulk of our research program is trying to find out, how do you get better? And we've identified actually a pretty sizable number of capabilities over the last 6 years that predict software delivery performance. And we've gathered them together in what we lovingly call the BFD, or the big and friendly diagram. which describes our research program, and which you probably won't be able to read unless you've got a pretty big screen in front of you. But fortunately, you can go to this URL, bit.ly/DORA-BFD, and find an interactive version of this diagram, which you can click through and see what all these different capabilities are. And indeed, this PDF you can get from visiting that URL and download our research program, print it out on the biggest paper you can possibly find and stick it on your wall, if that's the kind of thing you like to do. So I'm not going to go through this whole thing right now, but I will point out some key features of this. On the right, that kind of right-hand row, right in the middle, you've got organizational performance, which is, can we exceed our profitability, market share, productivity goals, those non-commercial things I talked about, like quality of products or services, operating efficiency, customer satisfaction, and so forth. There are a few things that impact or predict that, such as lean product management, which I'll talk about later, and software delivery performance, which I just talked about, which is a little bit below organizational performance. If you want to get better at software delivery performance, SDO performance, which is the combination of those 4 key metrics along with availability, there's basically 4 kind of key blocks of things that you can do. One is a bunch of technical practices called continuous delivery, and in the kind of bottom left are the technical practices, of which there are 14. Everything from test automation through to code maintainability, test data management, and so forth. Those things positively impact software delivery performance, and indeed a bunch of other things. Then some kind of management practices, limiting work in process and so forth. And then at the top, some product development practices. And then in the top right of that diagram, culture, which I'll talk about a bit more at the end. Culture is super important. We can measure culture, we can show its impact on software delivery performance, and we can show how you improve culture by implementing these product management, and technical practices that also impact software delivery performance. And then to the far left is effective leadership, which I'm not really going to talk about today, but having effective leadership is what enables you to implement these practices. So the key thing on this diagram, all those arrows indicate something predicting something else. So it's not just correlations on this diagram. The things, these arrows have 2 different ends, and then one thing impacts or predicts the other thing. So we can actually talk about how implementing technical practices impacts, for example, software delivery performance. And the interesting thing about this diagram is just like the way that it's been set up, which is how we validated it, that you have to have good leadership in order to implement the practices. These practices impact culture, and they impact your software delivery performance, and your software delivery performance and your culture impact your organizational performance. So that's kind of the very short version of this diagram. So I'm going to go through briefly a whole bunch of these different things. I'm going to talk about continuous delivery. I'm going to talk about the lean management and product development practices. I'm going to talk about culture. I'm going to talk about autonomous teams. So starting with the technical practices, and in particular, continuous delivery. Continuous delivery is about making releases boring. The idea is that at any time, you should be able to press a button and get your change into production during normal business hours. One of my key questions is, how many people are working outside business hours to do releases? And how many person hours are you spending outside normal business hours to do releases? And the correct answer to that question should be 0 if you're doing it right, because releasing should be something you can do at any time with 0 downtime at the click of a button or just running a single command. So that's what continuous delivery is, making it boring to release changes into production. There are a number of different practices, as I say, 14 different practices that go into continuous delivery. Stuff like continuous integration, deployment automation, shifting left on security, architecture. All these things impact software delivery performance. They also impact culture, so they make your culture better. And finally, they also reduce burnout on your teams. They reduce deployment pain, and they result in higher quality as measured in terms of the amount of rework you have to do. So again, quality is a big subject. I don't have time to cover it here, but I will say that we found a way to measure quality in terms of the amount of rework you have to do. So you do something, how much of your time is spent redoing things because you didn't do them right the first time. that's like a decent proxy variable for quality. And continuous delivery reduces the amount of time your team spend on rework so they can increase the amount of time they spend building features. A lot of these technical practices are focused on building quality in, which is an idea that comes from Lean. W. Edwards Deming, this dude here with the funky glasses, has 14 points on like a new way of doing management, which is what the Lean movement is fundamentally about. I like reading these. I set these to my students at UC Berkeley to write an essay on one of the 14 points because they're still pretty revolutionary. One of them is cease dependence on mass inspection to achieve quality, improve the process, and build quality into the product in the first place. And so this is what shifting left is about. Shifting left is about giving developers the tools and the knowledge and the ability to build quality, very generally understood, into the product. Because you can't take a product that isn't scalable, isn't highly available, and then after you've built it, wave the magic DevOps wand and have the DevOps unicorns come and magically make it performant and scalable and secure. That doesn't work. You have to build that stuff into the software as you're building it. So you better give developers tools to be able to do that. And the same with quality. You know, the idea that we're going to be dev complete, now we're going to find out if what we built was actually any good. Well, guess what? It's kind of too late. You should have done that as you were going along. The QAs are not going to wave the magic wand and suddenly fix your quality problems that were caused by developers not building quality software in the first place. And the key pattern in continuous delivery is this idea of a deployment pipeline, which is about getting you feedback as fast as possible. When I check in, I should have some tests that run very rapidly that give me feedback in a couple of minutes. Did I do anything really dumb? Those are my unit tests that run super fast. If those pass, I should have a set of automated acceptance tests that run probably a bit more slowly, but we're going to massively parallelize those, run them on the grid in the cloud, and get feedback in tens of minutes. Did we break any key scenarios, any user journeys in the system running in a production-like environment with a realistic data set? So acceptance tests, again, they should be running all the time. The moment they break, we should make it our highest priority to fix them. Then once the automated tests are passed, we should have builds that go downstream for exploratory testing, usability testing, performance testing, all these other kinds of testing that require more resources and take longer, but crucially, we should be running them all the time. And every time you're done with a run of exploratory testing, what you do is you pick up the latest build that's passed the automated tests and start again. And the key thing is we're not doing this stuff in big batch phases. We're doing this stuff continuously all the time throughout the software delivery lifecycle, so we can get feedback and fix problems as soon as they occur, rather than working in these big batches and finding out 2 weeks before we release that, oh, we've got a performance problem, we better re-architect our entire distributed system from scratch. Yikes. The same thing applies to security. We want to build security in. And what we found when we looked at this in 2018, building security into software development improves performance and security quality, software delivery performance. Elite performers build security in and are able to conduct security reviews and complete changes based on what they find from security reviews in the space of days, not weeks. Low performers, on the other hand, take weeks to do the reviews and then weeks to fix the problems that they find in those reviews. High performers are building security in by running security tests as part of their deployment pipeline. And one of the key jobs of InfoSec, as with much of this stuff, InfoSec moves from being like a gatekeeper to being an enabler, a team which helps developers build security in by giving them pre-approved libraries they can consume, giving them packages and tool chains they can use to do those security tests continuously throughout software delivery, and helping them do process improvement work. One of the biggest things you can do to build a high-performing team is focus on architecture. We found that architecture was super important. And when people talk about architecture, they often talk about Kubernetes and Docker and all these technologies, and the tools that they're using. And tools are great. I work for Google. We have some great tools, but tools actually are only important in as much as they enable particular outcomes. And what we found was these 5 outcomes were super, super important at predicting your software delivery performance. Number 1, can my team make large-scale changes to the design of its system without the permission of someone outside the team or depending on other teams? Number 2, can my team complete its work without needing fine-grained communication and coordination with people outside the team? Number 3, can my team deploy and release its product or service on demand independently of other services the product or service depends upon? Number 4, can my team do most of its testing on demand without requiring an integrated testing environment? Basically, can I run my acceptance tests on my developer workstation and have a good level of confidence that the software is releasable without having to stand up an entire staging environment with every single service in order to do any serious acceptance testing? Number 5, the key continuous delivery, like yes/no test. Can I perform deployments during normal business hours with negligible downtime? So you'll notice there's some things about organizational structure, and this is important for later, so hold that thought, and some things about your enterprise systems architecture as well. And it turns out those things are connected. And the research validates that. These 5 things basically are the same thing from the point of view of the statistical analysis, it turns out. And you need to add stats words here to make that make sense, which I don't have time to do now. But fundamentally, these things are connected. There's a law called Conway's law that says that the design of a system will reflect the design of the organization that produces that system. The organizational design and systems design are coupled. That's the crucial thing, and our research validates that that's the case. So you can say yes. We've had teams who can say yes to these 5 questions who are using mainframes. Equally, we've had teams that cannot say yes to these 5 questions who are using the latest WYSI architecture with microservices and Kubernetes and so forth. So the outcomes are really important. Tools are great, but they're only great in as much as you implement the outcomes. So keep an eye on these 5 things. Ask your teams and your organization, are we able to achieve these outcomes? And if not, you need to think about how you can enable those and how you can implement your tools in such a way that you enable these outcomes. So that's a brief overview of the technical practices. I want to switch gear a bit and talk about the management and product development practices. So just very briefly, what we find is this. We wanted to verify some management practices. And what we find is that these things, again, are very closely related. Things like limiting work in process, which means doing a smaller amount of things so that you can get those things done rather than trying to multitask and do like a whole ton of things but not getting any of them done. It's much better to focus on getting a few small things done rather than taking on too much stuff. Visual management, which means having visual displays of things like quality and how work is moving through the system. That, again, is something you can do with whiteboards and sticky notes. You don't need to do it with amazing kind of tools. Just make sure people can see what's going on broadly. Getting feedback from production and having that influence your business decisions that you make and your development decisions. And then finally, a lightweight change approval process. What we find consistently is that heavyweight change approval processes, such as having an external team approve your changes, like a change advisory board, does nothing to improve stability and substantially reduces the speed at which you can develop. So people often put additional process in place when in order to improve reliability. That doesn't work, basically. It's much better to have a lightweight change approval process based on peer review, where you're either pair programming or you have someone review your changes. Ideally in process, before you check in, you get someone to look over your code, either in person or remotely over Slack or Zoom or whatever, or just afterwards. You want that to be as just in time as possible. And again, what we find is that is substantially more effective. There's a big section on that in the 2019 State of DevOps report, if you want that to show your managers, to tell them that their kind of heavyweight change management process is bullshit. The other piece is product development practices. And again, what we find is that these ideas from lean product development of working in small batches, so having stories or requirements or features be just like 1 or 2 days, 1, 2, 3 days, not like a week or 2 weeks, breaking stuff into small chunks. And then as you're developing, breaking stuff into small chunks, not doing like several days of work off in a branch, but breaking that up into small chunks, which you're checking into trunk continuously. Working in small batches is effective. Making the flow of work visible, again, so you can see as work moves from idea through to production. gathering and implementing customer feedback, and finally, team experimentation. I can't tell you the number of teams that say they're agile, but actually they don't get to have any influence over the work they're doing or indeed the way they work. So anytime you see this thing where people say, we're going agile, we're all going to follow this exact process to the letter, and anyone who deviates will be punished, that's not agile. So teams have got to be able to try new ideas, both in terms of the features they build and in terms of their process and the way they work. And we show that these things all impact software delivery performance. They also contribute to reduced burnout on teams, and they impact culture. And lean product development directly impacts organizational performance, so profitability, market share, productivity, and those non-commercial things that I talked about as well. Again, this diagram, we're showing impact. We're not showing correlations, we're showing impact and prediction. So we talked about culture a bunch of times. What do we mean by culture? Well, what we find actually is there is a way to measure culture that is valid and reliable. And it's based on this work from a sociologist called Ron Westrum. Ron Westrum has been investigating safety outcomes in healthcare, aviation, nuclear facilities, and he basically found that he could predict the safety culture based on these 6 axes. To what extent do people cooperate effectively? Is there low cooperation, modest cooperation, or high cooperation? How do we treat people who bring us bad news? Do we shoot people who bring us bad news? Do we ignore people who bring us bad news? Or do we train people to bring us bad news so we can act on it as soon as possible before problems become catastrophic failures? Thirdly, how do we deal with risks and responsibilities? Are responsibilities avoided because you know if you're put in charge of something and something goes wrong, you're going to be fired? Responsibilities defined narrowly, so when something goes wrong, we know exactly who to blame. Or are risks shared because we know we succeed and fail as a team? How do we deal with bridging between different departments? Is that discouraged? Is it tolerated, or is it encouraged? You know, I've been called in as a consultant to teams, to technical teams, and I'm like, well, you know, let's have the product people there as well. And they're like, shh, we don't talk to the product people. Why don't you talk to the product people? Are they in a different country? Oh no, we just don't like them to know what we're doing because we're scared if we tell them we're refactoring, they'll beat us with sticks. So how do we deal with bridging? And then 2 things that are very closely related. How do we deal with failure, and how do we deal with novelty? In generative performance-oriented teams, when something goes wrong, we don't find out whose fault it was and then punish them. You know, oh, there was an outage in production. It was Jez's fault. Let's fire Jez. We realize that we're dealing with complex systems, and in complex systems, there is never one root cause. There's always multiple contributing factors, and it's very hard. There's an asymmetry. It's easy to look back in time and see what those causes were. It's very hard when you're doing something to predict that these 5 other things will interact in such a way that it causes an outage in production. So the interesting question is not, you know, whose fault was it? It was Jez's fault. The interesting question is, why did Jez make those mistakes? How could we get Jez better information and better tools so that when he does that thing again, it doesn't result in this cascading failure which causes an outage? The flip side of that is how we deal with novelty. In a culture where failure is punished, people will not try new things because there's a high chance of them going wrong, and when things go wrong, they will be punished. So you've got to build an organization where failure leads to inquiry. Otherwise, you will never see novelty in people trying new things because people won't do that because they're scared of failure. So again, you can measure this. You can ask questions, which is what we do, based on this typology, and find out whether people strongly agree or strongly disagree with those questions, and hence measure their culture. We find that culture predicts organizational performance and software delivery performance, and we find that all those capabilities I talked about, the technical, product management, those capabilities all impact culture. So if you want to improve your culture, you implement those technical practices, you implement those product development practices, you implement those lean management practices. That's how you change the culture, by implementing those practices. We were also really happy that we were able to reproduce these culture results using data from Google. So Google had this internal project called Project Aristotle, where they wanted to look at how to build high-performing Google teams. They thought it would be, hire some Stanford graduates, fire all the managers, and build everything in Node.js or whatever. And what they actually found, what they actually found was that these 5 things were actually what was important to building high-performing cultures. Psychological safety. Do team members feel safe to take risks and be vulnerable in front of each other? Dependability, structure and clarity, meaning and impact. And what we find is that when we were able to reproduce those results, what we found is that those first 2 things, psychological safety and dependability, those are the Westrom items that I showed you earlier. And then the bottom 3 things, structure and clarity, meaning and impact, those are the same as something else we measured called identity, and the items for identity I showed on the left. So we were able to reproduce our research using Google's research, which was pretty awesome. I also want to kind of tell a couple of stories about that and what a psychologically safe culture looks like. I really like this story from Etsy. So Etsy used to do an annual developer conference, and at the annual developer conference, they gave an award to the engineer who caused the biggest outage in the last year. That's the 3-armed sweater award. So if you, back in the day when you went to Etsy and you hit a 404, it would give you back a picture of a sweater with 3 arms. And so they give out a sweater with 3 arms to the engineer who causes the biggest production outage in the last year. So this is Rin Daniels. Rin Daniels pushed a change to prod that Rin could not possibly have known would take down prod. It was a tested change, but some weird interaction of some Apache module with the way that the module was rolled out and some configuration caused an outage. And Rin writes a blog post about that and talks about how it happens. And when Rin discovered this outage, they pinged on IRC, and the immediate response from everyone else on Rin's team was to ask, what help do you need? And that's what a psychologically safe culture looks like. It's about we help each other, we fix the problem, then we do a blameless post-mortem, and we find out how to improve the system and get people better information. Another story from Google. So Google runs these disaster recovery testing exercises every year, and they actually have a team in charge of building these scenarios. So Kripa Krishnan, for a really long time, ran that team, and she wrote a really nice blog post about those disaster recovery tests, where she talks about the plans they put together and what happened. And this piece is really crucial. For DIRT-style events to be successful, an organization first needs to accept system and process failures as a means of learning. We design tests that require engineers from several groups who might not normally work together to interact with each other. That way, should a real large-scale disaster ever strike, these people will already have strong working relationships. But last year in the State of DevOps report, we found that only 40% of respondents are actually performing disaster recovery testing at least annually on production infrastructure. So that's not good enough. So building a culture of high performance means building a culture where people are psychologically safe and ready to take risks, and we all work together and find problems and fix them as soon as possible. And we validate that by actually testing and imposing stress on our infrastructure and our teams in a controlled way in order to get better information and improve those systems. I want to end by talking a bit about, and actually just one more thing to talk about that briefly. We also found last year that holding retrospectives or learning reviews or post-mortems regularly directly impacts culture and creates a climate for learning. A climate for learning is when your organization treats learning as something that is strategic to the business, not as like a nice to have. So if you have a budget for going to conferences, if you're given time during your daily work to learn new skills and new technologies, that's evidence for having a climate of learning, as opposed to, well, guess what, you can go off and learn this new technology in your own time, and we're not going to give you time or budget to go to conferences or whatever. And having a climate for learning impacts organizational culture as well. So just want to talk briefly about autonomous teams and the importance of autonomous teams. We found out in our research in 2018 and 2019 that actually autonomy is really important. growing autonomous teams directly impacts software delivery performance and availability. So how do you create autonomous teams? It's not just about splitting teams up into smaller bits. It's about empowering them and giving the ability, for example, to experiment with their process and the way they work and let them work independently of each other. When you build autonomous teams, that also impacts trust and voice. Voice is when people feel comfortable speaking up. So when you build good autonomous teams, what you find is people trust each other and their management more. And that in turn means that people are more likely to speak up. And then when you have trust and voice, that impacts culture. So that was another result we found last year. We found also that functional outsourcing decreases performance. Functional outsourcing is when you have when you outsource QA or when you outsource operations, when you outsource like a whole function, basically. That reduces software delivery performance. What's preferred is if you have teams with all the necessary functions to get software from idea to delivery and operation within the team. So having cross-functional teams that are autonomous is super important. We also found out that a heavyweight change process negatively impacts performance. So again, they're not autonomous if they have to have somebody else approve everything they do. That's not autonomous. So you can see there's kind of a clear link here between this cultural piece around autonomy and some of the architectural stuff we talked about earlier. Can my team make large-scale changes to the design of its system without the permission of someone outside the team or depending on other teams? Can a team complete its work without needing fine-grained communication and coordination with people outside the team? Those architectural outcomes are kind of coupled or very similar to or related to some of these outcomes around the culture of autonomy and psychological safety and stuff like that. So this is something I find particularly interesting, the connection between technical architecture and the technical practices and the cultural outcomes and the extent to which those cultural outcomes directly impact the performance of your teams and your organization as a whole. And just one slide that I really like about autonomous teams in practice. This is from a presentation that's, I think, over 10 years old now by Reed Hastings, CEO of Netflix, where he talks, they released this whole presentation in like 2010, I think, which talks about their culture. And this one slide I really like, talks about teams being highly aligned and loosely coupled. Highly aligned means that the strategy and the goals are clear, specific, and broadly understood. And the interactions between teams are focused on that, not on low-level stuff like tactics and very fine-grained communication between teams. That requires a really substantial investment in management time around creating transparency around what the strategy and the goals are, ideally in measurable terms. This idea of OKRs floats around a lot. We use OKRs at Google. OKRs are often used as a tool to beat teams with. It's a very top-down thing. That doesn't work. OKRs have got to be created by teams and managed by teams. And you've got to be okay if you don't hit all your OKRs, but they should be aligned based on the strategic goals of the higher levels of your organization. And that's where the management investment really comes in important, in making sure that we're all aligned in terms of our kind of short and medium term goals, even though the teams have the ability to be involved in deciding what those are. And then those teams are loosely coupled, so they can get stuff done without relying on fine-grained communication. So that, I think, is a really nice example of what autonomy looks like in practice. And that's it. That's kind of all I have time for. If you have more questions or you want more information on this, all the stuff we've gathered is on cloud.google.com/DevOps. I kind of co-authored this book called Accelerate, where some of these results are presented as well. But we put as much as we can on cloud.google.com/DevOps, including a quick check where you can find out how you're doing in terms of those 4 key metrics and compare yourself to the rest of the industry. So check that out. And thank you very much for your time.